Okay, today we're going to do scale drawing. So what is a scale drawing? A scale drawing can be a reduction or an enlargement of a two-dimensional drawing. So reduction means get smaller, enlargement means get bigger. So real-life examples of scale drawings include photographs, because when you take a photograph of somebody, you don't print, you don't get an actual photograph of the actual size, it's a smaller version of it, right? Shadows, our shadows are smaller than what we actually are. Blueprints or floor plans. And models, like car models, a model of a car, models of airplanes, so models. And the activity we did the other day with Garfield was a scale, and then we increased it by a factor of 4. The scale factor represents the ratio, box that in, of the new drawing to the original. So the scale factor tells us how much our original figure was increased or decreased. So we're going to do an example of an enlargement. It says the photo below is being enlarged to form a 16 by 20. So let's box that in. Print. What is the scale factor being used to enlarge it? So it starts off as a 4 by 5 rectangle. We're going to make it bigger. And the 4 is going to go to a 16. The 5 is going to go to a 20. So I want to know how much that increased by. The way you do that is by following this formula. You take your new size, so in this case our new one is 16, and we divide it by our original. Well, it's now 16, it started as 4, so 16 over 4 is 4. Now we should get the same answer for every side. Our new one is 20, our original is 5. 20 divided by 5 is 4. So our scale factor is 4, and if you multiply that by 100, it's 400%. So this picture went from this to this, and it increased 400%. That's an enlargement. A reduction is when it gets smaller. So a map is being reduced to form a pocket-sized version. What is the scale factor being used to reduce the map? So it started as 24, went to 6. This went from 14 to 3.5. So our new side is 6. Our original side was 24. So when you simplify this, you get 1/4. Again, our new side is 3.5. Our original side is 14. And when you simplify this in your calculator, you get 1/4. So this was decreased or made smaller by 1/4. If you multiply that by 100, you get 25%. So this picture is 400% bigger. This one is 25% smaller. If you're not understanding, at this point, raise your hand and ask a question. If you do understand, put a smiley face next to enlargement over here. All right? All right, a scale factor greater than 1. So when our scale factor is greater than 1, so 4 is greater than 1, indicates an enlargement. When our scale factor is less than 1, so 1/4 is less than 1, that indicates a reduction. Okay, so on the back, the scale factor can also be multiplied by dimensions to create a scale. So we have this triangle here, and I want to use a scale factor of 3. So is that an enlargement or reduction? It's an enlargement because it's greater than 1. Then I'm going to use a scale factor of 1/2. That's a reduction, good, because it's less than 1. And then I'm going to do 1.5, which is an enlargement. Good, because it's greater than 1. So the first thing we have to do is find your original point. So let's find point A, which is right here. So to get to point A, we go over 1, up 1. So point A is at 1, 1. Point B, right here, we have to go over 1, 2, 3, 4, 5, 6, up 1. So this is at 6, 1. And point C, we go over 1, up 1, 2, 3, 4, 5, 6. So this is 1, 6. So to find what the new enlargement is, we're going to multiply the scale factor, which is 3, by each one of these. So 1 times 3 is 3. 1 times 3 is 3. So my new point, which is 3 times bigger than this point, would be located at 3, 3. Now I'm going to do the same thing for this point. I'm going to do 6 times 3, which is 18. 1 times 3, which is 3. So this point increased by 3 gives me this point. So what would this one be? 1 times 3 is 3. 6 times 3 is 18. All you're doing is taking your original points and multiplying them by your scale factor. Okay, let's do the same thing when our scale factor is 1/2. We're going to do 1 times 1/2. So when you do that in your calculator, you get 1/2. What's half of 1? 1/2. 1 times 1/2 is also 1/2. So when we shrink this point by 1/2, this is our new point. So let's shrink 6. 6 times 1/2 is 3. 1 times 1/2 is 1/2. Okay, let's shrink this point. 1 times 1/2 is 1/2. 6 times 1/2 is 3. So hit pause and do this column on your own. Your scale factor is 1.5. So go ahead and hit pause, hit play when you have the answers. Okay, so when you multiply 1 times 1.5, it's going to get bigger. So this is 1.5. 1 times 1.5 is 1.5. So those are your new points. 6 times 1.5 is 9. And you should be doing this on your calculator. 1 times 1.5 is 1.5. 1 times 1.5 is 1.5. 6 times 1.5 is 9. So if you were able to get that, good job. Put a star here if you got these right. Put a frown face if you got them wrong. Now, let's try some examples. It says triangle PQR, so you go in order. PQR is shown below. Its original lengths are multiplied by 2.5. What are the new side lengths of PQR? So these little apostrophes here mean prime. P prime, Q prime, R prime. That means it's our new figure. PQR is the original figure. The one with the apostrophes is the new figure. So what we're going to do is we're going to multiply every length by 2.5. So you're going to do 8 times 2.5, 17 times 2.5, and 15 times 2.5. When you do that, PQ should now be 20. QR would be 42.5. And PR would be what? Put that in your calculator. 15 times 2.5 would be 37.5. Good. Okay, let's try number 2. It says rectangle ABCD, so this is the original one. ABCD has been enlarged to form rectangle A prime, B prime, C prime, D prime. What is the scale factor? So go back to the first page and figure out how to find the scale factor. Remember, to the new over original. So hit pause and see if you can find the scale factor. So let's check how we did. Our new side is 18.6. Over our original side is 2.5. So in your calculator, when you do 18.6 over 2.5, you get Oh, that's not right. Hang on. Does anybody see what I did wrong here? Does this side and this side match up? No, I messed that up, sorry. This side actually matches with this side. They're just flipped, like this one's standing up on top of its head, this one's flipped to the side. So the new one is 7.5. The original was 2.5. That's a good, I'm glad I messed that up. That's a good thing to always check, is make sure you have the correct sides. So now when we do this, we do 7.5 over 2.5, and we get a factor of 3. So let's check to see if that's true for the other side. 18.6, that's the long side, matches up with 6.2. So we put that in our calculator. We do 18.6 over 6.2, which is also 3. So our scale factor is 3, or 300%. Okay, so let's try number 3. The two parallelograms below are similar. What is the missing link? So similar means same shape, different size. So we need to figure out what this one is. And the way you do that is you set up a proportion. So one thing we can do is we can find what the scale factor is. Now, did it go increase or decrease? It decreased, so it went from 9 to 6, right? So it got smaller. So if our original one is 6, our new one is 9, that simplifies to 2/3. So this got reduced by 2/3, which means this needs to get reduced by 2/3. So there's a couple ways you can do that. You can do 15 times 2/3, and if you do that in your calculator, you get an answer of 10. So my missing side is 10. The other way to do it is just to set up two proportions. So my new side is 6. My original was 9. That should equal the same proportion with the other sides. So if my original side is x, my new side is 15. So when you cross multiply and divide, you do 6 times 15, which is 90. 90 divided by 9 is 10. So you're still getting the same answer. You can do it either way. You can figure out what the scale factor is and reduce it by that, or you can set up proportions, where on top you have your new, and on the bottom you have your originals. Okay, number 4. Susie walks 1.5 miles to school. When she looks at the map, it's shown the scale to be 1 centimeter equals 0.5 miles. What is the distance between Susie's house and her school on the map? So take a minute and see if you can figure out this one on your own, okay? So what we're going to do is set up those boxes, and we'll do boxes a lot on these just to keep things organized. We have miles and centimeters, right? So I'll put miles on top, centimeters on the bottom. We know she walks to school 1.5 miles. We want to know how far that is on the map, so we don't know this answer. We do know that on the map, 0.5 miles equals 1 centimeter. So centimeters are on the bottom, miles are on top. Our scale, which is what's on the map, goes together, 1 and 0.5, and then the other information goes together. So we're just going to cross multiply and divide here. So when you do this, you do 1.5 times 1, which is 1.5. Then you divide by 0.5, and you get an answer of 3. It's on the bottom, so it's centimeters. So 1.5 miles to school is 3 centimeters on the map. Okay, so on your homework, you're just going to follow the directions. For problem 1, they give you the figure, the scale, and they want you to find the new information. So figure A, the scale is 1/4. We want to find what the new length is. So the length is 1, 2, 3, 4. So I'm going to do 4 times 1/4, which gives me a new length of 1. So when I decrease this by 1/4, I get a side of 1. So I want you to finish that on your own. All right, raise your hand if you have any questions.